This is one of those rare occasions when my wonderful, insightful, genius lecture notes from yesterday still survives, and so I can pick up right where we left off. And you'll notice that we were dealing with Descartes, and I was noting with you that the two successors to Descartes, though they both claim to follow his methodology of rigorous deductive logic, go, oddly enough, in two different directions. And yet, strangely, they have a lot in common. They're both bizarre. I guess that's what they mainly have in common. But you'll see at least some degree of attempt to resolve the problem that we saw in Descartes with interactionism. And this problem of interactionism is related to my contribution, one of the rare original contributions you'll get from me in this class, that when you start with the mind, you lose, Eric. And why do I say that? What's the point of that little thought?
Because if you start with your mind as your fundamental logical foundation, you end up traveling so far away from what's called, saving the appearances.
Okay, good.
That you lose the world around you.
Okay, that's good. And I appreciate using the expression saving the appearances. That is not original to me. That's a common phrase that you will hear if you do further philosophical studies. So, kind of get that in your mind. But Descartes' trying to save the appearances. He's trying to give us back the world fundamentally in the form that we think it is. We think there's a world out there. I look outside and see a pine tree. I go, yeah, there's a pine tree out there. Well, Spinoza's not so sure. For Leibniz, there's no pine tree out there. Trust me, there ain't any pine trees out there, you see. For Descartes, there is. He's saving the appearances. These guys sacrifice the appearances really just by continuing to do what Descartes taught them to do. Locke is going to be the same way. He will be commonsensical. But he's going to start with the world, But ultimately, he can't give us back the mind, and that especially is true by the time we get to Hume. So we're going to see the same sort of deal. We're going to start with Locke, we'll look at Berkeley, we'll look at Hume. Both of these guys, in a sense, lose the mind in the process, and so there's a kind of an interesting symmetry here. Kant comes along and tries to give both back, give it all back. And he creates the modern world in some ways. All right, so Leibniz. Let's talk about Leibniz a little bit. His name is Gottfried. Gottfried. Gottfried Leibniz. Born 1646. Dies in 1716. Absolutely the opposite of Spinoza in his personality. Spinoza was morose, quiet, introspective, a loner. He liked to sit alone and grind lenses and think deep thoughts, breathing that glass that was in the air, He was offered a professorship, that is, Spinoza was offered a professorship at one point, turned it down. He didn't like to be in front of people. He just wanted to do his work privately. And, of course, the fact that he'd been excommunicated from his Jewish family and from his Jewish world only served to create even more of a kind of lonely spirit there, Leibniz is just the opposite. He was popular, he was outgoing, he was kind of like an early Ben Franklin. Ben Franklin was very affable, well-loved, internationally famous, brilliant, genius. He was in the court in France, and they loved to have him over. He's on a first-name basis with Marie Antoinette. I mean, this guy gets around, And that's kind of the way Leibniz is. He was, from that point of view, he was a very significant player in the House of Hanover in Germany. Why are we interested in the House of Hanover? Not from a philosophical point of view, just from a general interest point of view. Why House of Hanover?
I remember one of England's kings is from the House of Hanover, and the king.
You are quite correct, and I'm very impressed with that answer. It's substantially what I was hoping to hear. Can you fill in any further blanks there?
Well, I think George IV was the cousin to the king of Germany. George IV, king of England, was cousin to the king of Germany at the time of World War II.
Yeah, I think, well, I don't know if it's 2 or 1. I think World War I maybe. But, yeah, World War I, yeah. Kaiser Wilhelm I. Yeah, right. By the Second World War, there are no kings in Germany, you know. It was the Weimar Republic and all of that and so on. All right, well, that's good. William I is the king of England following the end of what ruling family? This has nothing to do with philosophy, but it's kind of interesting to connect the dots a little bit. William I comes in when? Do you recall?
After the Plantagenets, is that right?
I'm not sure about that. Well, say it again. No, it's after. Okay, later than that. Good. Yeah. No, the time frames are way off here, okay? Just let me help you a little bit. All right, you've got Tudor Stuart England, right? The last Stuart is named. Yeah, tick, tick, tick. I don't know, the history song probably knows. Who's the last Stuart? No, well, James the Second of England. You may be thinking of James the Sixth of Scotland, who became James the First of England. Then you've got William the First, then the interregnum, then Charles, sorry, scratch that, pardon me. Let's try it again from the top. James the First, Charles the First, Charles the Second, James the Second, who rules from 1685 until he's deposed in the Glorious Revolution. You all know this, don't you? In 1688. And then who comes in following James II? James II is the last Stuart. Then who comes in? You should know this, yeah, Gabe? No? Okay, the people that come in, Thank you.
It's the guy, Cranmer?
No, that's the interregnum. That's Oliver Cromwell, that's who you're thinking of. William and Mary of the House of Orange. And the House of Orange is related not to England, but to what country? The House of Orange is connected to the country of?
To the country of Germany.
No, it is not Germany. It is?
Norway?
Not Norway, but you're getting closer. It is? Netherlands. Okay, Holland. Okay, House of Orange. William of Orange comes in, married to Mary, the daughter of James II, and they rule for about 20 years, and they die without children. And so the next relative, who is the legitimate heir to the throne of England, oddly enough, is German, the House of Hanover. So George I takes the throne of England in 1716, the year of the death of Leibniz, but Leibniz was actually a counselor to George I in Germany, and he was a counselor to the House of Hanover in Germany. And that has precious little to do with our conversation, but it's always good to review this stuff, not bad. Have a little European history. bouncing around in your brain thing, right? See, now that's the look. That's the look that Mr. Palvin was giving you a bad time about. Whatever, Mr. Gore, you know. No, just kidding. All right, so anyway, let's, a little more pertinent stuff here. He is a philosopher, he's a scientist, he's a mathematician, he's a diplomat, he's a librarian, he's a lawyer. I will never test you on that, just trying to impress you. The guy was pretty bright, and he did a whole lot of stuff. Some things that you may want to tuck away in the category of trivia. He is the guy who, in 1694, for the first time that we're aware of in the history of mathematics, this is 1694, used the term that you have all mastered in your mathematical studies. And the term is, I don't know if you guessed this, function. So when you graph, you know, something and you get a curve and something functions with something, I guess that's what you do, don't you? You kind of recognize that. I used to teach this, but that was years ago. Okay, this is, yeah, I am serious. I did. The student, you didn't have me for math, did you? Did you? Yeah, it was your class. I had you guys 3 years running. That's why the people in the class of Joel, like Travis, this would be Dick, you know, and others have a huge black hole in their mathematical background. This huge, you know, kind of abyss where they know nothing, where they should have had 7th, 8th, and 9th grade math. But Brittany is a math major, and she turned out, so hey, I'm not feeling so bad. Anyway, Leibniz gives us the term function. Leibniz also is the co-inventor. He independently invented, along with one other major genius of the age, the discipline of what? He gave us what branch of mathematics that some of you in your senior year would study? Haley? Calculus. It's always been an interesting debate, you know, who got it first. They did not work together. They were not aware of each other. Both of them sort of simultaneously work out the fundamentals of calculus. Yes?
The other guy is Descartes.
The other guy is not Descartes. The other guy is... Descartes was a mathematician, and he might have come up with it, but the other guy was... Yes?
The French mathematician Newton.
Newton, see. Or I should say, oui. Yes, so Newton and Leibniz came up with it. He also is credited with coming up with the notion of the conservation of energy, which is usually also attributed to Newton, but Leibniz also came up with something of that. All right. Leibniz Father was a professor at the University of Leipzig, where he was born but died before Gottfried was 6 years old. So he lost his father at a young age. However, by the age of 12, Leibniz had mastered Greek and Latin, teaching himself. That is, he didn't have formal education in either. He was just a native genius. And so he, both Greek and Latin. By the time he was 20, he had mastered all of the standard college textbooks in the fields of mathematics, philosophy, theology, and law. He was a voracious reader, a student that would make all of the rest of us kind of hate him, you know, if he were around. Except he was such a friendly, outgoing, helpful, kind of humble guy. Humble in a cocky sort of way, you know the type. Humble, but not really. Kind of, anyway, he was that sort of character. All right, enough of that. He, as I say, the bulk of his professional career, he traveled around the world. He was well known in his day, but primarily he was kind of a diplomat, courtier in the House of Hanover. That was really how he earned a living. His philosophy, unlike that of Spinoza, was just written on the side. Well, Spinoza wrote on the side too, but Spinoza wrote these big, voluminous works. Leibniz just kind of tossed off little scraps of paper. It was little notations here and there, notes in his diary, letters he wrote, and so people later sort of formulated his thought. But there is one thing that he wrote which became quite important and probably is the fundamental notion of his philosophy, and it's a work called Monadology. Monadology, in which he delineates his understanding of monads. And this is where we have to start to get Leibniz. All right. What is a monad? Monads are what Leibniz says are the little particles that make up all of reality. It's in this sense that he's the opposite of Spinoza. Spinoza is a substance monist. That's the term you want to use with Spinoza. And, what does that mean? Bottom line, everything is one great expansive reality. We are just waves on the sea, right? For Leibniz, we go just the opposite direction. Spinoza has everything as one great expansive reality that he calls substance, aka nature, aka God. On the other hand, Leibniz says, wait a minute. We have to, in our philosophical musings, try to find the simplest expression of reality. And so as he begins to think about this, he thinks to move from complex to simple usually implies moving from large to small. I want to get to the simplest level of reality. And the simplest level of reality in the final analysis cannot be any divisible thing. Now just work with me here, because there's a strange sense in which, while Spinoza reminds us of Parmenides, as I think all of you were thinking, Leibniz kind of reminds me of who? Thank you, Gabriel. Want to know if anyone else wants to play? Remember just let me say it again before I call on Sarah. For Leibniz, the simplest level is the level that becomes ultimately indivisible. Indivisible. And that would sound a little bit like who? Sarah? Oh, you're close. That's not a bad thought. Yeah, you could hear the atomic theory going on, but it's not quite atomic theory. Oh, the seeds idea, not bad. Okay, good. Yeah, Jonathan? The boundless. I would put boundless. That's not bad. I'd still put him a little bit more. Oh, okay. I thought Sarah was going to say it. Go ahead, Jansen. Isn't this great, though? Listen, all these names bouncing around, this is all, and you could make this argument for any one of them. That's not bad. Go ahead.
You told us to know that at the very beginning of the year, it was Heraclitus, wasn't it?
Oh, well, no, actually not Heraclitus. I would say, what? Interesting. Oh, did I say that? Oh, interesting, yeah. Sometimes I say things in my sleep, I just kind of. All right, well, who I'm thinking of, who I'm thinking of here actually is Zeno. I'm wrong. That's right, well, that's highly probable. That could be. All right, now listen. Zeno keeps telling us we have to divide infinitely that which we call space, right? And that's what Leibniz says. Leibniz says if I'm going to get to the very simplest level of reality, to the very simplest level of anything I think about, then I have to get to that level which is not divisible. But how tiny must something be if it is no longer divisible? How tiny, Reagan, must something be if I can no longer divide it into two, like I divide it in half, then how tiny must it be? Infinitely tiny. It becomes that mathematical point we've been talking about. Leibniz says the only thing that is truly simple is therefore that which is truly spiritual, because it cannot be extended in space and time. It must be infinitely small, and when we get to things that are infinitely small, we get to things that are purely mental or spiritual. Now, what you should be thinking here is, you see that you can see why Leibniz is still a rationalist, because he's still playing around with the problem of interactionism, right? The mathematical point. But he's really going a very different direction from Spinoza. He's going in the direction of teeniness, And this very tiny thing is called the monad. This tiny, tiny, tiny thing that I cannot adequately write on the board, because anything I put there has extension. It takes up space. But it's infinitely small, and it's what he calls the monad. Everything is a monad. And thus all of reality is made up of an infinite number of infinitely small monads, beginning with God, who is the first monad. No, not the biggest, because God does not take up space. God is purely mental. Right, go ahead.
So, get your time machine, go back, grab Leibniz, force him in, kidnap him, and then say, hey, look, we got the atomic theory. And what would he say to the fact that we have pretty closely experimentally confirmed that there's a specific size, physical size of the atom?
He would say, well, now wait a minute. When you look at the components of the atom, the closer you look, the more you see that even those tiny little particles are really, in the final analysis, pure what? Energy. And how much space does pure energy take up? 0. Many people have thought Leibniz had an intuition of quantum mechanics before the scientific progress had been made to actually discover it. He's really quite contemporary in that sense. So the problem of interaction, again, that Descartes was wrestling with really doesn't exist in Leibniz, because ultimately everything is mental. Everything is pure energy, if I can put it in more contemporary terms. And that includes, of course, not just you and me, but tables, chairs, everything. And we would say it's really true. Everything, even that clock up there, as physical as it appears, if I could really look at it in an infinitely close way, I would see that it is actually not really there. It's just energy. And energy can't really be anywhere in that sense. It's monadic. Now, the monads are all, in a sense, the result of the first great monad, which is God. God has brought all the other monads into being. But every other monad is necessarily imperfect. But God has entrusted each of these monads with a certain limited in a sense, perception of all the others. This does sound bizarre, I realize, but just, be patient. There is no direct interaction among all these monads. There is only a kind of correlation, or what Leibniz calls pre-established harmony. There is no causality. There's no sense in which one thing causes another. What appears to be causality is just that pre-established harmony. So God has, hang on just a second, God has not only created each monad, but he has entrusted in each monad its own history. And that history has within it a pre-established harmony with all the other monads. So, God has established that when I take this monad, to wit, a marker.
Is that only one or is that a thing?
Well, good question. Complicated question. But in terms of thinking about a thing as a thing, we could call it, let's call it a monad without exploring that too deeply, all right? I drop it, and it generates a sound, and I have this intuition that, the dropping marker has caused the sound, right? That's kind of the normal way we think about experiences in life. Things cause things. One event flows from a prior event. It is the result of it. But that creates all kinds of problems in this purely rational kind of scheme of things, and so the only way Leibniz can really account for what appears to be causation is what he calls pre-established harmony. Namely, God created the monad gore to drop the monad pin, and you experienced, as individual monads, by God's pre-established harmony, the experience of the sound. Nothing caused it. God just determined that all those things were going to happen in a wonderful, pre-established harmony.
So do we ever hear sound?
Now, all I want to know, what you hear, you have experiences that God has ordained for you. Now, the thing that always impresses me is the same guy who came up with calculus. He's not. Well, I was just going to say he's not an idiot, but, maybe the jury's still out on this one. But anyway, and without exploring him more deeply to try to see what problems he's solving, it's one of these situations where the medicine is worse than the disease, the problems he's trying to solve, I think, become infinitely more complicated given his solution to them than what we had originally. But there are some very deep philosophical problems, metaphysical problems about the nature of reality, and both these guys are trying to solve them using pure deduction, And of course, for Leibniz, and follow him here, Leibniz is fascinated with the idea of simplicity. And for him, simplicity ultimately has to be purely mental. Start with the mind, lose the world. None of these guys can really give us back the world. They give us a basically mental world. For Spinoza, it's substance monism. The reality is kind of this spiritual thing we call substance, nature, or God. But it's not really the world that we think is out there. For Leibniz, it's this mental thing we call the monad. Descartes comes the closest to giving us back the world, but he can't really quite get us there because of the problem of interactionism, you see. Both these guys solved Descartes' problems, but wow, what a solution. I like Descartes better, but he hasn't really solved it either, you see. You start with pure mind, you can never quite get to that external reality we think is out there called the world. Yeah.
Is there like a hierarchy of monads
Well, yes, there are. Yes, I am a superior monad to that stool.
But then you're also a superior monad to your thumb monad.
Yes.
A superior monad
Yeah.
to the skin monad,
Yeah.
to the
Yeah.
particle monad.
Right. And in a sense, you could conceive of monads within monads in that sense. Now, he doesn't put it that way, but he does. Let me just say to you, Gabriel, if you're really interested, it's not unmanageable. I think the copy I saw at Whitworth Library was something on the order of 200 pages and loose change or something like that. And more readable than Spinoza and tightly reasoned, you know. So he does, this is where he kind of reminds me of Zeno. He shows the absurdity of extension. He shows the absurdity of something being infinitely divisible, you know, that problem. It's interesting, isn't it, that he, the inventor of calculus, which really is a mathematical discipline concerned with things infinitely small, finding a point on a curve. I mean, you know, you can see where his mind, he himself reaches the conclusion that ultimately this appearance of limits and, you know, reaching that infinitely tiny limit demands that reality really is not extended at all. And while his math, you know, is sort of a way of measuring that which is not real in some sense, it's you can see where his, you know, thinking is sort of correlating the one with the other. So anyway, I have about 6 minutes. Let me give you one other little thought. This is kind of separate, but it's another thing for which Leibniz